Please open in your learning workbook to page 201. We're now going to solve some ALEKS problems involving transformations of logarithmic functions. Below is the graph of y equals log base 2 of x, translated to become the graph of f of x equals log base 2 of the difference x minus 4, subtract 2. Okay, this is clearly a transformations problem, and our parent function is given to us as y equals log base 2 of x. We've actually looked at this graph in a previous video. We came up with the x values by raising the base 2 to different integer powers, which gave us these values of x. And then the y values are the integer powers that we selected. Here's the graph, logarithmic with a vertical asymptote at the y-axis. Okay, now we have to translate this, and the order of transformations tells us that we should look for horizontal shifting first. That would be adding or subtracting that is close to x. And so we see that right here. This is indicative of a horizontal shift to the right 4 spaces. All right, and in this problem, there are no instances of stretching, shrinking, or reflecting, but we do have a vertical shift indicated by this subtract 2 outside far from x. And so this is a vertical shift down 2. Okay, so we've got two translations here, right and down. We need to figure out which coordinates change and how for each one of those. All right, let's do right 4. Let's say you're standing at the origin and you go right 4. 1, 2, 3, 4. You end up at 4. You add 4 when you move to the right. So all of the x's, we're going to add 4. So let's make our table of points. And we'll add 4 to all of our x's. Here we go. 1, 2, 3, 4, 5 rows. And we're adding 4. All right, so 4 add 4 is 8. 2 add 4 is 6. 1 add 4 is 5. Half add 4 is 4 1/2. Quarter add 4 is 4 1/4. All right, there we go. Now to the y values. All right, y values, down 2. So that means we take all of our y values and we subtract 2. I can see I made that blue arrow go a little bit too far. I made the arrow before I made my table. We fix that really quickly here. So the adding was happening here, and the subtracting is happening here. Okay, great. So now we're going to go ahead and get our new y values. We have to subtract 2. 2 minus 2, 0. 1 minus 2, negative 1. 0 minus 2, negative 2. Negative 1 minus 2, negative 3. Negative 2 minus 2, negative 4. Okay, so now we have the new points, so we can create our new graph. So let's go ahead and do that. All of our y's are non-positive, and our x's are some fairly large values. So that means that our graph is going to be mostly in quadrant 4. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8 for the x. 1, 2, 3, down to negative 4 for the y values. And let's plot some points. Here we go. All right, 8, 0. That would be the x-intercept. 6, negative 1 would be here. 5, negative 2 would be here. 4 1/2, negative 3. Well, 4 1/2 is halfway between 4 and 5, so 4 1/2, negative 3 would be here. 4 1/4, negative 4. Well, 4 1/4 would be between 4 and 4 1/2, and that would be here. And we can connect all those dots together, and that creates the graph of our logarithmic function. Let's talk about where the asymptote goes. All right, so we know that a logarithmic function has a vertical asymptote. And the only kind of transformation that can get that to be somewhere else is a shift left or right. Do we have one of those in this problem? Yes, we have shift right 4. So instead of being on the y-axis, it's 4 units to the right of that. The new location of the vertical asymptote is at 4. This is consistent with the points that we've plotted. We can see that our points were approaching that asymptote, and so this allows us to draw a more complete version of our graph. We can see that we are approaching that vertical asymptote as we go through all of these points. Okay, so there we go. We have now created the graph of our transformed function. One more thing that I'd like to talk about before we call this video done, and that would be how this is done when you're doing this problem in LX. In LX, they're going to give you this graph, and once you identify your transformation as right 4 and down 2, you hover your mouse over the graph where you see a little hand icon, you click and hold your mouse down to grab a hold of the graph, and then physically move it right 4 spaces and down 2, and release your mouse, and it's going to move the graph from the orange location to the pink location. All right, there we go. That's the end of this problem.